friends, welcome to Videos Online Academic Tutorial. Thanks for watching our videos online. Please, if you haven't subscribed, please do well to press the subscribe button and notification bell and have to see all of our educative videos online. Remember to share this video with your friends, families, relatives, and colleagues at home. Thank you and God bless you. Amen. Today I'm going to be considering a topic called energy and chemical reaction. We're talking about energy and chemical reaction. What is the relationship between energy and a chemical reaction? As we know that energy can be defined as the ability to do work. And how does this relate to chemical reaction? Reaction cannot take place without energy, because for a reaction to take place, a reactant must possess what we call an activation energy. For a chemical reaction to take place between two reactants, they must possess a type of energy, must possess an amount of energy known as activation energy. That is, activation energy is the minimum amount of energy required for a chemical reaction to occur. A plus B to form C plus D as our product. These are reactants. And this is our reactant, and these are our products. Now, for reactant to change to products, it must possess a minimum amount of energy called activation energy. And that's why we are told that in the conservation of energy, that energy can never be destroyed, not created, but can transfer from one form to another. You can see that this matter transforming from A and B to C and D. So now we know that energy accompanies a particular reaction. And what are the forms of energy that accompanies the chemical reaction? Number one, we have the heat energy, the light energy, or the sound energy. These are the three forms of energy that accompanies a chemical reaction. Heat energy, light or sound energy are the forms of energy that accompanies a chemical reaction. And that's why in some reactions we have pop sound. For example, we are testing for We are testing for CO2 gas. We have pop sound because in that particular reaction, the form of energy that accompanies it is is sound energy, and some energy also produce light, and some other energy also produce heat. Now, one thing that we need to know that every substance possesses what we call heat content. That is, each mole of a substance contains what? Each mole of a substance has a characteristic heat content, has a characteristic heat content, also known as Also known as enthalpy. Now, note that we said that each mole of a substance has a characteristic heat content, also known as enthalpy, denoted by H. Now, meaning that each term here has an enthalpy, a particular amount of heat content, and the change in heat content, the change in enthalpy, which is known as heat content of a particular reaction, change in enthalpy of a chemical reaction, change in H is given as change in H now for this particular reaction is given as the heat content of the product. The heat content of the product minus the heat content of the reactant. So in other words, change in H is now given as you add the heat content of the product, Hc plus Hd minus Ha plus Hb. So that's about the change in heat content of a chemical reaction. Note that its content or enthalpy is measured in joules. Is measured in joules or kilowatt, kilojoules, or kilojoules, or kilojoules. Let me write it in full, kilojoules. Now, whenever the heat content of a particular reaction is negative, whenever the heat content is negative, that is, one change in H is minus, that is negative, we call that what? Type of reaction an exothermic what? Reaction, an exothermic reaction, an exothermic reaction. So whenever you have change in H to what? Negative, which is minus, the reaction is called exothermic what? Reaction. That is, exothermic reaction can be defined as the reaction which involve the release of heat energy to the environment. Reaction is the type of reaction which releases heat to the what? To the surroundings. So when change in H is equal to positive, we have what? We have endothermic what? Endothermic reaction. We have endothermic reaction. Whenever this one is negative, we have exothermic. Whenever this one is positive, we have what? Endothermic reaction. And this is a type of reaction in which heat is absorbed from the what? Environment. In which heat is absorbed from the environment. Now, we are talking about what? Exothermic reaction. What are the examples of exothermic reaction? We can find that in about process of production of what? Of ammonia. When you react nitrogen with hydrogen to produce ammonia, it releases some amount of heat energy to the surrounding. So, it's an example of exothermic reaction. While an exothermic reaction involves melting of ice. Whenever you bring an ice block out of the refrigerator and it begins to melt, it's absorbing heat from the environment in order to melt, and we call that reaction what? Endothermic what? Reaction. So whenever change in heat is minus what? Is minus, then it's exothermic. Whenever change in heat is what? Positive, it is what? Endothermic. Now we have the relationship between what? The relationship between entropy and what? Relation between what? Entropy and enthalpy of the what? Of the particular reaction, enthalpy. Relation between what? Entropy and what? Enthalpy. Now we're talking about the relationship between what? Entropy and enthalpy. What is entropy? Entropy is defined. The entropy is defined. Entropy S is defined as the degree of disorderliness of a system. The degree of disorderliness in a what? In a particular reaction or in the system is what we call what? Entropy. And change in entropy can be calculated as well. Change in entropy, that is, the change in entropy can only be calculated by what? The what? The products. The entropy in the product minus entropy on what? On the reactant. And also, the change in entropy can be calculated from enthalpy change, which is the heat content, all over what? Temperature. Where change in H is what? Enthalpy what? Enthalpy change. Change in enthalpy or enthalpy change. Change in enthalpy. And T is the what? Absolute what? Absolute temperature. Measure in Kelvin. Absolute temperature. So the relationship between entropy and enthalpy is given as what? Change in H all over what? T. And also, we also have the relationship between what? The relationship between entropy, enthalpy, and what? And free energy. And free energy. When I talk about free energy, what do you mean by free energy? Free energy, also known as what? Gibbs what? Gibbs energy. Is defined as the energy required or energy available to do what? Now, the free energy of a system or a chemical reaction is the energy available to do what? Is the energy available to what? To do what? And it is given as what? The free Gibb energy is mathematically expressed as change in G is equal to what? Change in H minus what? T change in what? X. Free Gibbs energy or what? Free energy is given as what? Change in G is equal to change in H minus what? Change in S. We know that what? This is what? This is the heat content known as enthalpy. This is what? The entropy known as what? Change in what? X. And we use this free energy or this energy to check the spontaneity of what? Reaction. The spontaneity of what? The spontaneity of a chemical what? Reaction. How do we use this to check the spontaneity of a chemical reaction? Now, how do we use this? Now, whenever what? Whenever G is equal to what? 0, we said what? The reaction is in what? Is in equilibrium. Whenever the value of G is what? Is equal to 0, you said the reaction is in equilibrium. Whenever the G is equal to minus, is equal to negative or minus, we said that what? We said that the reaction is spontaneous. Reaction is spontaneous. Reaction is spontaneous. Spontaneous. That is, the reaction is spontaneous. But when the G is equal to positive, it is what? Non-spontaneous. Non-spontaneous. So that's that. Whenever we have G equal to 0, reaction is in equilibrium. Whenever G is equal to negative, the reaction is spontaneous. And whenever the G is equal to positive, the reaction is non-spontaneous. So before us are jam questions in order to test what we have done so far. Now, the first question says a reaction takes place spontaneously if A, G is equal to 0, B, S is less than 0, and H is greater than 0. C, H is less than T multiplied by change in S, and D, G is greater than 0. To check for the spontaneity of a particular reaction, we need to make sure free gives us energy, which is what? Which is given as change in G is equal to what? Change in H minus what? Minus T change in what? X. Now, for a reaction to be spontaneous now, change in G must be what? Must be negative. That is, change in G. That is, change in G must be less than what? 0. Now, to be less than 0 now, or to be negative, or change in G to be negative, meaning that what? Change in H must be greater than what? Must be less than what? T change in S. Change in H must be less than T change in S. That is, what is here must be less than what is here. For us to be for this to be negative. So meaning that for G to be negative now, change in G is negative. If what? Change in H is less than what? T change in what? S. So that is the only condition where we can have change in what? In G. And the option here is what? Is C. So to have your reaction to be spontaneous, in other words, for G to be negative, the what? The enthalpy change must be less than the product of what? Temperature multiplied by change in entropy. So question number 2 now. The standard enthalpies of formation of CO2, H2O, and CO in kilojoule per mole are minus 394, minus 242, and minus 110 respectively. The standard enthalpies of CO2, H2O, and CO. That is the standard enthalpy of that word. HCO2 is equal to HCO2 is what? Minus what? 394. The water is what? H2O is given as what? Minus 242. That of what? Carbon monoxide is given as what? Minus 110 respectively. Okay. The question says, what is the standard enthalpy change? What is the standard enthalpy change for the reaction CO plus what? H2O to give what? CO2 plus H2. What is the what? Standard enthalpy change for the reaction CO plus H2O to to give CO2 plus H2. Now, to calculate what? The standard enthalpy change, that is change in enthalpy. We now do what? Don't forget, change in enthalpy is same as what? Enthalpy of the product minus enthalpy of the what? Reactant. So in this case, we are going to use what? Enthalpy of the product minus what? Enthalpy of the what? Reactant, because we are given what? The standard enthalpies of formation of the reactant and the product. So, which one is the reactant? We have the reactant here, we have the product here, and we have the reactant here. But we are only given what? The CO2, the enthalpy for the CO2 is minus 394, which is the product. So we are given what? So for the product side, we have CO2, which is this, the enthalpy. It's now the enthalpy of CO2. The enthalpy of CO2, now, which is the product. That is the only what product we are given to us. And mind you, that, so we are given what? The enthalpy of what? Of CO2 only as the product. So the enthalpy of CO2 minus the enthalpy of what? Of the water plus the enthalpy of the carbon monoxide. So the enthalpy of the water, the enthalpy of the water plus the enthalpy of the what? Of the CO, which are the two reactants given to us. You can see they give us the enthalpy of the what? Of the HCO and the enthalpy of the water. So now let's solve it now. We have what? Minus what? 394 now, minus open bracket. Now add the enthalpy of the water together, which is minus 242. Now plus what? Plus that of CO, which is what? Plus minus 110. Please note that. So this is what? Minus 394 minus 242 minus what? 110. What do we get? Minus 242 minus 110. Because plus times minus give you minus. Okay. So it will give what? Minus 352. Note that what? Minus times plus will give you minus. That's the same thing as saying that minus 242 minus what? 110. So now when you press it on calculator, you are going to get minus what? 352. So minus times minus will give you plus. Minus 394 plus 352. So minus what? 394 minus on one side to give what? Minus 42 minus 42 kilojoule per watt per mole. Minus 42 kilojoule per mole. So that is that about our answer. Note that what? The enthalpy change is equal to the product minus what? The enthalpy of the product minus the what? The reactant. And our product here is what? CO. And our what? Reactant is CO plus what? H2. So our product here is what? CO2. Please take note of that. So the option here is what? Minus what? 42 is the option there, minus 42. So that is A. Minus 42 kilojoule per mole. Please note that because this is what? Kilojoule. So minus what? 42 kilojoule per mole. Minus 42 kilojoule per mole. Minus 42 kilojoule per mole. Option what? A. So that one is what? Minus kilojoule. So minus 42 kilojoule per mole. So that's that about what? Question number 2. Now let's go to question number 3. Now question number 3 says if the change in free Gibbs energy of the system is what? Minus 899 joule per mole. And the entropy change is 10 joule per mole. At 25 degrees Celsius, calculate the enthalpy change. If the change in free energy, that is number 3 now, the change in free energy is what? Is minus 899 joule per mole. Joule per mole. Then the entropy change in S is what? 10 joule per what? Mole. At what? at T is equal to 25 degrees Celsius, that's this room temperature, we are going to take it to Kelvin, plus 273 to Kelvin. So we are going to have 298 Kelvin. Calculate the change in enthalpy. We are asked to calculate what? The change in enthalpy, that is change in H. Now, if this energy is given as well, change in G is equal to what? Change in H minus T change in X. So we are asked to calculate change in H. So substitute this one in values now. So we have to what? Calculate change in H, just transfer everything here. So we have what? Change in G minus what? Okay, when I'm transferring everything here now, it becomes plus change plus T change in X equal to change in H. So to get change in H now, we have change in G plus what? T change in S. So not to waste of our time, let's substitute our value. Change in G is minus 899 plus, now our what? Entropy here is 10. No, our entropy here is 10. Our temperature here is 298. 298 multiplied by what? 10. 298 multiplied by 10. So what do we have? We have what? Change in H is equal to minus 899 plus 2,980. So what is our answer? So what's our answer? So minus 899 minus 899 plus what? 2,980. What do we have? We have what? Plus 2,081 plus 2,081. Now the unit here is what? Joule per mole. Joule per mole. So that's our what? Change in enthalpy. Change in enthalpy is what? Plus 2,881. So this is plus. So whenever you do have 6 sign, it is plus. So this is plus. So option what? Option A. So that's that about question number 3. Number 3 says that in a chemical reaction, which of the following condition indicates that maximum yield of the product will be obtained? A. Equilibrium constant is very large. B. H minus T change in S is equal to 0. Then change H greater than TS. Now, which of these will maximize the products of the reaction? Now, when we look at it very well, equilibrium constant is very large. That this case is constant. Is that the correct answer? No. H minus T change in S equal to what? 0. This is very, very what? Important. This is very, very important. This is what? This is our answer. Whenever you wanted to maximize the product, you must ensure that what? The change in energy is equal to what? 0. That is, energy must be constant. So to maximize your product, the change in gives energy. To maximize your product, that's number 3. Number 4. To maximize your product, the change in gives energy, which is H minus what? T change in S, must be equal to what? 0. There must not be variation in your energy for you to maximize what? Your product. So that's why this B is our answer. So please take note of that. Please take note of that. So the next one, which is we are given a reaction which is C plus H2O plus hydrogen plus CO. Change in G for the reaction at 1300 Kelvin is minus 42. We can see that in number 5 question, G is equal to minus what? 42 kilojoule per what? Mole. Now when G is what? Is negative, we say the reaction is spontaneous. That is, the reaction occurs naturally. We don't need to what? Force the reaction. The reaction will occur naturally. So, in that sense, at this temperature now, the reaction is A, not feasible, B, at equilibrium, C, feasible, D, exothermic. Now, since the what? The reaction is having change in G to be negative, which is that the reaction will be spontaneous, showing that the reaction will be spontaneous, definitely the reaction will be obvious and it will be visible for us to see, because the change in Gibbs energy is minus what? 42, and it will make the reaction to occur spontaneously. So the reaction here will be what? Will be visible. The reaction will be what? Visible. The reaction will be visible because of the spontaneity of the reaction. So since the reaction is spontaneous, it will be what? Visible, to be visible. So the option here is option C. Option C says that Rs plus HF to give Rf plus Hs. Rs plus Hf to give Rf plus Hs. From this equation above, it can be deduced that, now look at it, the heat content given to us here, the change in heat content here is minus 65.7. And whenever we have what? Heat content to be minus. Whenever we have heat content to be minus 65.7, what does that one suggest to us? It suggests that it is an exothermic reaction, because change in H is negative when we have an exothermic reaction. And to have an exothermic reaction, what does it mean? To have an exothermic reaction, what does it mean? It means that what? H P minus what? HR. That's a change in what? Change in what? H. And in order to have change in H negative, it means that what? The product is less than what? The what? The reactant. That is, the heat content of the product is less than the what? The heat content of the what? Reactant. Meaning that, in other words, or we can put it like that what? The reactant, the heat content of the reactant is greater than the heat content of what? Of the product. So, in other words, we are still saying the same thing. So, now, they have say if this is the what? Reaction now, and this is the change in heat content. From this equation above, it can be deduced that the heat content of the reactant is lower than that of what? The product. Now, is the heat content lower than that of the product? Is the heat content, you said the heat content of the reactant is lower than the product. Is the heat content of the reactant lower than the product? No. Because here we have the heat content of the product less than the what? Reactant. Or the reactant is what? Greater than the product. So, this is not the option. Now, the option B says the heat content of the reactant is higher, which is very, very true. The heat content of the reactant, because for us to have negative change in H, the reactant must be higher than the product. So the heat content of the reactant is higher than the product. The option is what? B. So that's that about that. We have come to the end of today's class. If this video has helped you, please remember to like the video and share with your fellow colleagues. So see you next time, and God bless you.